Hello everybody, it's Mr. Trochet with another video lesson. We got 7.1.4, how can I solve it? Equations with fractions and decimal coefficients. What's a coefficient? Well, basically a coefficient is the number right in front of the variable. So if I were to go ahead and say, for example, 2x plus 1, this 2 is a coefficient. That 2 right there. So a coefficient is the fancy term or math term for the number in front of the variable. And the coefficients are very important, as you will see here. One thing is you will develop strategies to solve new type of equations with coefficients that are fractions. And so we're going to talk about some things like reciprocals and things like that in a quick section. So recall that coefficients are a numerical part of a term, such as 5 and 5x, or 2/3 and 2/3 x squared. All right, so we want to make sure that we are able to approach this relatively easily. So anyways, we are going to be doing excuse me real quick. Give me 1 second. Just got a message. All right, I apologize for that. Anyways, so here we go, 7-39. We're going to get started. Going to use some red right there. Are we there yet? So basically, they keep asking, are we there yet? By the way, don't do that to your parents. And they say, basically, what I can tell you is that we have driven 100 miles and we're 2/5 of the way there. So pulling a little math on them. How long is this trip anyways? And then they started to figure out how long this trip is. Well, they don't know, but they know that they're 2/5 of the way there and they've already gone 100 miles. So based on the proportions and ratios they have, they could figure out what that is right there. All right. So they started thinking about what they can do. The first thing here, as we see, is that we have this Linda's method, and there's the Lee's method. And so what they're going to do is they're going to try to figure out how to find out what this missing x is. And both ways are a good way to find out. So explain both Linda's work and Lee's works, illustration, situation described by the mother. Well, here we have more of a number line technique. All right, so we have a number line, and each line is 2/5. So we have 100 is 2/5. So that means x has to equal 5/5 in a way, or 1. That's why the 1 is for. You can also look at it as percent. So 2/5 is 20, 40, 60, 40%. So if 40% is 100, I could figure out how to use my proportion there to figure out what x is in one way. Here, they have this x, and they times it by 2/5 to get 100. Well, how can I figure out the reverse to get to x? Well, one way to do that is to do the opposite. So we multiply by 2/5. This way, we would multiply by 5/2. And that would give us the other way around too. But anyways, what does x represent in each diagram? X represents the total miles of the trip. All right, that's what the x represents in this. I don't know if my computer's really slow. That's not good. Give me 1 second. Close some windows down. Maybe close some Spotify. I don't know what else we have here. Okay, so anyways, what equation could represent the situation? So use the scale factor or multiplier to represent the situation in the equation. Okay, give me 1 second. My computer's really slow. All right, and so here it is. So basically, we have use some blue here. My scale factor. So my scale factor is going to be this 2/5 right here. That's what we're going to be multiplying it by. Write an equation to represent the situation. So 2/5 x should equal 100 because we have 2/5 and x and 100 right there. So that's pretty much what we're doing. How I did this before earlier in the early years was that I would do 100 divided by 2/5. And that would equal x because this is like a fraction. 100 divided by 2/5. Now that looks kind of funky in terms of that. So in order to solve that, it's another time for another place. Anyways, But basically, it's going to be 2/5 x times that. So because if I have a fraction, and I have to get rid of a denominator, in order to get rid of a denominator, you multiply by the denominator, and that will equal 1. But what I do on one side, I do to the other side. So that means 2/5 times x is going to equal 100. And that's kind of the same thing of how I did this here. So 100 divided by 2/5. You can also use percent. You can use decimals, whatever. Is the answer going to be more than or less than 100 miles? Well, here's the thing. If I went 2/5, right? I went 2/5 and I got 100. What is 5/5 going to be? Well, 5/5 should be more than 100 because 5/5 is greater than 2/5. So that means 100 is 2/5. That means the miles should be greater than. So it should be greater because 5/5 is greater than 2/5 because 100 is 2/5. Okay, let's move on to the next one here. Let's keep going down. Are we going to do 740? Let me check the altitude card. Do I want to do 740? I do. I do not. I do not want to do 740. Let's see. Yeah, let's do 741 then. So 741. So yeah, 741. Lee thinks what he knows about similar triangles can help. All right. So review 722, which involves similar triangles. We're not going to do that. How are the scale factors related? What do I want to do 741? I don't think I want to do 741. I apologize. Give me 1 second. Okay, I was wrong. I need to do 740 and not 741. That's the one I wanted to do. All right, so 740. When I look at my diagram, I see the total distance is 2.5 times the distance we've driven, because here we have 1, and then we have another 2, and then we have a half. There's a half right there. So that's 1, 2, 1/2. So 2.5 right there. Boop, boop, boop. All right. So do you agree? How can you add labels to Linda's diagram to show 2 and 1/2? Well, I'm going to just do this right now. I already did it actually. So this is a 1. This is 2. And then this is a half. 1/2. So 1, 2, half. How can you add labels to Linda's diagram to show 2.5 times the distance? You can say 2/5 here. We have 2/5. We have another 2/5 here, and then we have 1/5 here. So that's 1, 2, and a half there. You can do that. You can say 100 miles. Why is it? Oh, there we go. You can say 100 miles. Let me use this one. You can say 100 miles, 100 miles, and then 50 miles as well. Like you can do it by this way. You can do it this way. I mean, there's no wrong way as long as you're accurate in terms of what you're saying. So that's pretty much it. So how long is the trip? How do you know? So 2.5 times 100, and that should be 250 miles. All right, that should be 250 miles because we're doing 2.5 times 100. All right, let's go to 742. 742. All right, as Linda and Lee were talking about the problem, their mother overheard and offered them another strategy. Here's how I would start solving the problem. She showed them the work at the right, and then they did this. A, I see a giant 1, exclaimed Lee. So here's my giant 1. Here's my giant 1. This is my giant 1 right here, and I always box it, and I draw a 1 right down the middle. Where's the giant 1? Help rewrite the left side of the equation. So you can rewrite this in the sense of like, so 2/5 x equals 100, and then I divide by 2/5, divide by 2/5, and that is my giant 1 right there. One way of making sense is 100 divided by 2/5 can also be rewritten as 100 divided by 2/5 like this. So if I have 100 divided by 2/5 equals blank, how can I rewrite this? Well, we can do keep, change, flip. And so we're going to keep the 100. we're going to change this to multiplication, and we're going to flip this as the reciprocal of 5 halves. So that's going to be 500 divided by 2, which is 250. That's one way. You can explain how how many 2/5 are in 100. All right, so there's 250 total miles for our trip. So that's one way you can do that. Yeah, that's pretty much what I would do in terms of that. Let's see. Moving on to the next problem. We're almost done. Wow, that was quick. Lee began to wonder how his diagram could help him solve mother's equation. He did this below. And so this is where we're talking about the reciprocal. This is where it's like, instead of fraction busters and stuff, that this is like where it's at. You have 2/5 times x. So we have a coefficient of 2/5. Now, what did they do here? What did they do here? Well, they did something here, and they multiplied both sides by 5 halves. Why would they do that? Well, let's take a look at this. How does Lee work relate to the similar triangles diagram? So basically, the similar triangles diagram above, what that's saying here is when I go from x to 2/5, I get 100. Well, I don't know what x is, but you can work backwards like a circle. So I do 100 times 5 halves, and you do the reciprocal to get to x. Now, you're probably wondering how that makes sense, but basically, it's like saying if I go from 5 to 6 and I have to multiply, what would I multiply 5 into 6, 5 to get to 6? Well, I would multiply 5, let me go ahead, 5 times 6/5. Why would I do 5 times 6/5? Well, the reason why I do that is because this is over 1, right? And so if that's over 1, where's my thing at? Oh, there we go. There we go. Oh, it's over here. Sorry, I didn't know where it was. All right, so that means this 5 and this 5 cross out, and then I'm left with 6 over 1, which equals this 6. So I multiply, in order to get from 5 to 6 by multiplying, I multiply with the 5 on the bottom and then whatever on top if I'm trying to get to 6. So as long as the 5 is on the bottom, the 5s will cancel out and whatever's on the numerator will be there. So if I wanted to go from 6 to 5, well, I just use the same thing. I would just use 6 at the bottom and 5 on top. So then these 6s would pretty much become a 1, and then I would have 5 left over, and that's how I'd get to 5. So again, this one would be 5, 6, this one to 6 5s. It's the reciprocal. So if I'm going to 5 to 6, it's whatever fraction it is. If I want to go backwards, I flip it over and get the reverse. So I have 2/5 here to get to 100. Well, from 100, how do I get back? I have to flip the fraction to 5 halves, and then that will give me x. So 100 times 5 halves gives you x, and that's why we do that. All right, so let's go back. Let's clear the board here. Let's go back to this one. So that's how you answer that problem. That's how is it related. I just went over that. What is 5 halves times 2/5 x equal? Well, that cancels out, and then the 2's cancel out, and so I'm just left with x. So x is going to equal to 100 times 5 halves. Now, that's what that's going to equal to. All right. So when that equals that, yeah, that's pretty much it. Finish Lee's work to solve for x. Check your solution. So then I got to solve for x. So that's 500 divided by 2 because that's a fraction. So then that's going to equal x. So the x equals 250. All right, 250 miles, obviously, because we were talking about miles. And then we check our solution. So we're going to go plug this back into our original equation. So 2/5 times 250 equals 100. Well, that's going to be 500 on top with a 5 at the bottom. That's going to equal 100 equals 100. Bring that down. And so 2 times 250 equals 500. 500 divided by 5. All right, we're dividing by 5 is going to be 100. So that's it. All right. That was a pretty quick lesson. How much time do I have? Let's see. Let's pause real quick. There we go. Let's just call it a day there. Let me pause real quick. Let's call it a day. Go ahead and work on the homework. I wish you the best of luck. We're just working on some fractions and some coefficients. So remember, reciprocal. If you want to get rid of this right here, if you want to get rid of 2/5 x, then you just go 5/2. All right, 5's cross out, 2's cross out, but make sure you do it on both sides. Okay. All right, that's pretty much it. I hope you have a great day, and let me know if you have any questions. All right, bye-bye.